Ginside.com. Ginside.com.
Selection sort. Take data that is out of order and put it into order. Selection sort requires fewer swaps than bubble sort. It's a slight improvement over bubble sort. It's not a revolutionary change. Also, recall from bubble sort, we tried to pick up the largest number we could find and move it to the end of the array, and then we reduced the size of the data by 1 and move the larger number down. In selection sort, we're going to take the opposite tact. We're going to scan down the data, looking for the smallest or minimum number we can find, and move it to the beginning of the array. We will then exclude that smaller number and repeat the process over and over again till our data is sorted. Let's set up a few local variables for this code to work. Outer will control the outer loop. Inner will control the inner loop. Min, or minimum, is the smallest number we've found. It's the index or subscript of the smallest number we found during our scan. And of course, temp is a temporary variable we use to swap two numbers in the array. Starting the outer loop, we'll begin at position 0, or the beginning of the array. This will be our target position. The goal is to move the smallest number we can find to the outer index or subscript. We'll look at outer less than array.length minus 1. This is the true-false statement that's going to control whether we stay in the loop. 0 less than 4 is clearly a true statement right now. We are obviously going to go in and execute the body of the loop right now. Min equals outer. The value 30 at index 0 is the minimum. We'll always start with the minimum value we can find during our scan. Min is the index or subscript of the smallest number we have looked at so far. The inner loop is the scan. It's going to go down the array looking for a smaller number than the minimum. Inner will always start at outer plus 1, so we've got to compare two positions. We're going to compare outer to inner, and if it's smaller, that's the number we want to swap at the end of the scan. Inner less than the array.length, 1 less than 5, is clearly a true statement. So once again, we're going inside the loop to execute the body of the loop. Remember, the goal here is to find the smallest number. The array of inner, which is 20, is clearly less than the minimum value we've seen so far, 30. As a true statement, we're going to execute the command min equals inner. And when we do that, we'll set a new min. See that min has the value of 1? When min has the value of 1, we're saying this value in index 1 is the minimum or smallest value we can find. The value 20 at index 1 is the new minimum value or smallest value. We'll hit the end of the loop and spin back up. That's what loops do. When we get back up, we'll increment the inner value. We'll move down the array looking for something smaller. Again, the goal of selection sort is to identify the smallest number and move it to the beginning of the array. 2 less than 5 is a true statement, so we're going to go inside the loop and execute the code once again. But look what's changed. Array sub inner is 50. That is not less than 20. That is a false statement. As a false statement, it's going to skip the if code and head to the end of the loop. 50 is not less than, so let's go back up and continue looking. Notice the red arrow here. The red arrow is indicating the current min index. Min is set to 1. 20 is the smallest value we've looked at so far. Inner plus plus will increment inner and move it down to the next position in the array. 3 less than 5 is still a true statement. As a true statement, we are going to execute the body of the loop once again. Array sub inner is 10. That is clearly less than 20, the current minimum. So as a true statement, we have found a smaller value. Every time this if statement is true, We have found a smaller value. It's time to execute the body of the if statement. Min equals inner says set min to 3. Notice how the red arrow has moved. The red arrow is pointing to the smallest number we have found. The value 10 at index 3 is the new minimum. Looping back up, because that's what loops do, we will increment inner once again. Inner plus plus will say check position 4. Remember, we're still doing the scan. We're still looking for the smallest value we can find in this array. 4 less than 5 is a true statement. As a true statement, we will execute the body of the loop. But when we get into the body of the loop, array sub inner, or the 40 at the end of the array, is not less than 10. That is a false statement. As a false statement, we will skip the if block and hit the end of the loop once again. At the end of the loop, we will increment inner once again. Now notice inner has moved to position 5. There is no position 5 in the array. We've moved off the end of the array. So when we come back and check, is inner 5 less than the length of the array, which is also 5, that is a false statement, and this inner loop is done. When this inner loop is done, we will exit the inner loop and continue on with the program. Notice we found the smallest value. Min is set to 3, the position of the minimum value in this array. So it's time to swap. And where are we going to swap? We're going to swap with outer. We'll say temp equals array sub outer. Start the swap of outer 30 and min 10, the smallest value, by moving outer to temp. The 30 that is in position 0 of the array has now moved to temp. While it's safely there, we can then move the 10 over. Array sub outer equals array sub min. We're going to move that 10. See that 10? It just moved down to position 0. It wiped out the 30 in position 0, but that's okay because we have it in temp. Temp contains that 30. Let's swap the minimum 10 with the outer position, which contained 30, and we have completed the swap. Outer has the smallest value. Remember, the goal of selection sort is to scan this entire array, find the smallest number, and move it to our target or outer position. And that's what we've done. We've identified 10 as the minimum value, and we've moved it to that first position. We'll hit the end of the outer loop. When we hit the end of the outer loop, we'll loop back up and repeat the outer loop. Watch what happens now. Outer plus plus will move the outer target to the next position in the array. Notice that outer's gone to 1. We're moving to here and saying move the minimum value we can find to position 1. 1 less than 4 is clearly a true statement. So as a true statement, we will go inside the loop. Inside the loop, we'll set min equal to outer. The value 20 at index 1 becomes our new minimum value. This, notice the arrow, is our minimum value. Inner always starts next to outer. We're going to compare the two values, outer and the number next to it. So inner is going to be this position right here, position 2 of the array. 2 less than 5 is clearly a true statement, so we're going to go inside the for loop and scan the remainder of the data looking for a smaller value. When we find the smallest value, we'll move it to that beginning position. Comparing the 50 less than 20, that is clearly a false statement. When I compare these two numbers, 50 is not less than 20, so we will skip the if portion, hit the end of the loop, loop back up and repeat the loop. Inner plus plus will move down the array looking for a smaller value. Let's look at position 3 and see if it's smaller. 3 less than 5 is a true statement, so going into the body of the loop. 30 less than 20 is a false statement. Now look at the two arrows. This is our minimum value here. This is the value we're currently looking at. Is the new value smaller than the old one? Obviously not. So let's skip the if portion of this statement and go back to the end of the loop, where we'll loop back up and repeat the inner loop once again. Inner plus plus says move to position 4 of the array. Move down the array looking for a smaller value. 4 less than 5 is a true statement. As a true statement, we'll go inside the body of the loop and execute the body of the loop. Array sub inner, or 40, less than array sub min, which is 20, is clearly a false statement. We have not found a smaller value. So we'll skip the body of the if, hit the end of the loop, and loop back up and repeat the inner loop. Inner plus plus sends us to 5. We're going to move down the array. Off the end of the array, there is no slot 5 in this array. Since there is no slot 5 in the array, when we check inner less than array sub length, 5 less than 5 is clearly a false statement. The inner loop is done. It's time to exit the inner loop. We've found the smallest value. We've scanned down the data and we've determined 20 at position min is the smallest value. Technically, we don't have to do this swap. Technically, 20 is just going to swap with its own position. We could add another if statement here, but that another if statement would probably take so long that we're just going to go ahead and swap the numbers. Although 20 is just swapping with itself. Start the swap of outer 20 with the minimum value 20. It's the same value, but we're going to execute the commands either way. Note the smallest value min 20 is at outer 1. The subscript 20 equals 20. So all we're doing is really just swapping position 1 with itself. The swap of the minimum 20 and the outer 20 is complete. This is a do nothing swap. We really haven't changed anything. Sometimes that's the way selection sort works. The first number is the smallest number. We'll hit the end of the loop and we'll go back up and repeat the outer loop. Outer plus plus will move the outer target to the next position in the array. Notice how our outer has gone to 2. We're going to start here. The next scan we're going to do is start here at position 2, or outer, and go down the array looking for the smallest value. 2 less than 4 is clearly a true statement, so we're going to go inside the for loop and execute the body of the outer for loop. Min equals outer, that's our default. The value 50 at index 2 is the minimum. The start of our scan always is the minimum value until we look at the other numbers. Inner starts next to outer. We're going to compare the two values, the one at position inner, the one at position outer. We're going to compare these two adjacent numbers and see which one is smaller. 3 less than 5 is a true statement. As a true statement, we go inside the body of the for loop. Array sub inner, that 30, is clearly less than array sub min, which is a 50. That is a true statement. We have found a smaller value. We're comparing these two indexes in the array. Position 2, the minimum, with inner, position 3, and position 3 is smaller, so let's set a new minimum. Min equals inner. The value 30 at index 3 is the new minimum. So we're going to set this as our minimum value. It is smaller. We'll loop back up and repeat the inner loop. Inner plus plus says go to the inner position of 4. At the inner position of 4, we need to compare that last number and see if it's smaller. 4 less than 5 is a true statement, so let's go inside and check the if. 40 of array sub inner less than 30, which is our current minimum, well, that is a false statement. As a false statement, we will ignore the body of the if statement and continue on with the loop. We'll hit the end of the loop and back up and repeat the inner loop. Inner plus plus will move down the array. Off the end, once again, there is no slot 5 of this array, so inner has moved way off the end of this array. But that's okay because 5 less than 5 is false. The inner loop is done. We have, once again, found the smallest value. 30 is the smallest value in the 3 remaining values. So that 30 needs to be swapped. We'll exit the inner for loop and we'll execute our swap code. We'll start the swap of outer, which is 50, and min 30, the smallest value remaining. we'll move that 50 out of the array into the temp variable. Array sub outer equals array sub min. We will move the 30 over to the minimum position of the array. Remember, selection sort wants to move the smallest number it can to the beginning of the array. So that 30 is moving closer to the beginning of the array. Then that 50 we saved, the swap of min and 30, and the outer 50 is complete. The temp that was stored safely there got moved back into the array. Notice how outer has the smallest remaining number left in the array, 30. Let's hit the end of the loop and go back up and repeat the outer loop once again. Move outer, or the target, to the next position in the array. Outer, or position 3, is our new target position. Move the smallest number we can to this position in the array. 3 less than 4 is a true statement, so we're going to enter the for loop and execute the body of the outer for loop. Min equals outer. The value 50 at index 3 is considered the minimum. Remember, we always start the minimum at the start of our scan. Inner equals outer plus 1. Inner starts next to outer. Let's compare the two values, inner and outer's position in the array. 4 less than 5 is a true statement, so we're going to execute the body of the inner for loop. Array sub inner, which is 40. Look at this arrow over here. That's array sub inner. This 40 is clearly less than array sub min, the 50. As a true statement, we have found a smaller number. We're going to execute the body of the if statement. Min equals inner. The value 40 at index 4 is the new minimum. We want to select 40 as the minimum of the remaining numbers. We'll still hit the end of the while loop, the inner while loop, and back up and repeat the inner loop. Inner plus plus, move down the array, off the end of the array. There is no slot 5 of this array, so 5 less than 5 is a false statement. The inner loop is done. We have found the smallest value in the remaining data. It's 40. We'll exit the inner loop and go to the swap code. Once in the swap code, the 50 in the outer position of the array will be moved over to the temp variable. There's our 50. That's saving this value right there. Note the smallest remaining value, min, or 40, is now at the outer position. We've moved that 40 over to here. We wiped out the 50 that was in the array, but that's okay because 50 was safely stored in temp. The swap of the min, 40, and the outer, 50, is complete. Outer has the smallest remaining number, 40. We'll hit the end of the outer loop. We'll back up and repeat the outer loop, but things are going to change this time. Outer plus plus is going to move outer to the last position in the array. There's only one number left to search, but one number isn't enough to compare. So 4 less than 4 is false. The last array slot, the outer loop, is there and the sort is done. Notice the -1 on this. We stop when we reach this position of the array. When we reach this position of the array, there's nobody to compare 52, so we can stop when outer reaches that position in the array. Notice where this code is going to go. When this statement goes to false, this code will exit the outer loop and our selection sort is done. And our data, 10, 20, 30, 40, 50, is in order, as you would expect at the completion of a selection sort. The speed advantage over bubble sort is the swap is done outside the inner loop. Bubble sort swaps every time. Selection sort swaps once per pass. If this inner loop spins 4 times, then at most I'll do 4 swaps. See this code that I have boxed up? In bubble sort, that was inside the for loop. Therefore, swapping occurred much more often. In selection sort, this code is outside the inner loop. The most it can execute is the number of times the outer loop executes. So selection sort is a slight speed improvement over bubble sort. It is not a revolutionary difference, but it does minimize the number of swaps the algorithm has to do, and the fewer swaps, the faster the code can run. Insertion sort. Take data that is out of order and put it into order. This time we're going to use a shift instead of a swap. Once again, we'll slightly improve the performance over bubble or selection sort. Insertion sort is sort of the electric slide of sort algorithms. We'll declare some local variables to control the outer loop, control the inner loop, and hold the insert value while searching. Again, insertion sort pulls a number out of the array, shifts a bunch of data over, and then inserts it back into the array. That's where it gets the name insertion sort. Outer, once again, is controlling the outer loop. Outer is our target. Shift larger values to this position. Outer is our target position. We want to move the big numbers to the target position. Notice how it's starting at position 1. It's not starting at 0. It's starting at position 1, and outer will move down to the end of the array. 1 less than 5 is a true statement. This is a standard for loop here. While this statement is true, we're going to go inside the for loop and execute the code. Insert equals data sub outer. 20 is going to be what's called the insert value. Larger values to the left will be shifted to the right before 20 is inserted back into the array. What we've done here is we've pulled this 20 out of the array and safely stored it into the insert variable. Anybody that's bigger than 20 will be shifted over before we insert 20 back into the array. That's why this is called insertion sort. We pull a number out of the array, we shift bigger values over, and then we insert the number back into the array. Inner equals outer. Inner will move backwards when larger values need to be shifted. We'll always start inner equal to outer. This will be clearer once we get into the loop. Here's a while loop. Inner greater than 0, 1 greater than 0. That's a true statement. And this is the and symbol right here. And 30 is greater than or equal to 20. Data of inner minus 1, that 30 right there, is greater than our insert value of 20. Anybody that's larger than our insert value needs to be shifted over. Now here's the big difference. Instead of swapping numbers to move them, we're going to shift. 30 is larger than insert, which is 20. Shift larger values to the right, no swap. We're going to take data of inner minus 1. That's that 30 right there. That's inner minus 1 right there. We're going to shift it over one position to the right to data sub inner. Data sub inner is right there, position 1. We've just moved that 30 over one position. Anybody that's bigger than 20 has to slide or shift over. Once we've shifted over, we'll set inner minus minus. What we're going to do is subtract 1 from inner. We're going to move backwards. Inner is going to move backwards towards the beginning of the array. Inner is going to go to 0. We're going to hit the end of the while loop. Inner loops back up to see if there's more to shift. When we get back up though, inner greater than 0, is 0 greater than 0? No, it isn't. That is a false statement. If this half of the and is false, then the whole thing has to be false. When we reach position 0, there's nothing left to shift. We're going to exit the inner while loop. And when we exit the inner while loop, we're going to say data sub inner equals insert. This is the insert of insertion sort. After shifting larger values over, insert the 20 back into the array. Note 20 and 30 are in order. What we just did is we took this 20 that was in the insert variable and we inserted it back into the array position 0. That's a good thing. Look at 20 and 30 are now in order. We'll hit the end of the outer loop. and we'll back up. Note, from the start of the array to outer, the array is sorted. Outer plus plus will bump outer to the next position in the array. Position 2 is now our outer position. 2 less than 5 is a true statement. So we're going to continue on this loop, and we're going to go inside the body of the outer loop and see if we can shift again. 50 is the insert value. The larger values to the left will be shifted. This is our best case scenario. No one to the left is larger than, I don't think we're going to have to shift. Notice how this 50 is larger than everybody to the left. That is a good thing for insertion sort. Inner will be set to outer. Inner will move backwards when larger values need to be shifted. Once again, this is the best case. We're not going to find any larger values. Look what happens when that occurs. 2 less than 0 is a true statement. That is true. And 30 greater than 50, that is a false statement. 30 greater than 50, this second half of the and is a false statement. That's a good thing. Woohoo! That means we don't have to shift. If the number next to 50 is not larger than 50, there's no shifting needed. This is where the speed advantage of insertion sort occurs. This while loop never even executes. We decide right away that there's nothing to shift. We'll leave the while loop. We'll come down and do data sub inner equals insert. This is the insert of insertion sort. The 50 is inserted right back where it was. No shift occurred. Fast. Good values don't move. 50 is in a sorted position when you look at these three numbers. All we did is we pulled 50 out and put it right back where it was. That's a good thing. It speeds up the sort. We'll hit the end of the outer loop and we'll back up. Note, from the start of the array to outer, the array is sorted. Look at 20. Look at 30. Look at 50. This data is in sorted order. Therefore, we can move on to the next value. Outer plus plus says bump outer to the next position in the array. Look at where outer went. We're going to go to position 3, pull it out, and shift everybody over that is bigger. 3 less than 5 is a true statement. As a true statement, we're going to enter the body of the for loop. We'll set inner equal to data of outer. 10, the insert value. Anything larger to the left will be shifted. Now this is the worst case scenario. All the numbers to the left are larger. We're going to have to shift everybody over. 50 was our best case. 10, because it's smaller than everybody else, is sort of our worst case scenario. I have a feeling we're going to have to do a lot of shifting. Inner equals outer. Inner will move backwards when larger values need to be shifted. Once again, this is a worst case scenario. Everybody to the left of 10 is bigger. We're going to have to shift them all over. Inner greater than 0. 3 greater than 0. Well, that's true. Data sub inner minus 1 greater than or equal to insert. That's 50 greater than or equal to 10. That is true. When both sides of the and are true, the result is true. That means we have to do a shift. That 50 needs to move over. 50 is larger than our insert value. We're going to shift larger values to the right over. There's no swap required. I didn't swap to get 50 moving over there. I just did a single assignment and the 50 shifted over. Notice how the 50 wiped out the 10. That is not a problem because 10 is safely in that insert variable. We'll do minus minus inner. Inner moves to the left to see if there's more values to shift. And I have a feeling there are. Inner just moved to position 2, and we will be looking at numbers to the left of that. Hit the end of the while loop. Inner loops back up to see if there is more to shift. Inner 2 is greater than 0. That's true. And the 30 at inner minus 1 is greater than or equal to 10. So this both sides are true. We need to shift. That 30 is bigger than the insert value. 30 needs to shift. Data of inner equals data of inner minus 1. That's that 30 moving over here. There's inner minus 1. It needs to move to inner. The 30 just shifted over. Wiped out that redundant 50, but that's okay. Anybody that's larger than insert has to shift over, and the 30 just shifted. Inner minus minus is inner moving down the array. Inner's moving down to this position here. We'll hit the end of the inner loop. We'll back up and see if there's more to shift. 1 greater than 0 is a true statement. 20 greater than or equal to 10. We're looking at this 20 right here. And yeah, it's bigger than our insert value. It needs to shift. Going inside the inner loop, we will perform the shift. The 20 is larger than the insert value of 10. Shift larger values to the right. Notice how we're not swapping, we're just shifting. The 20 just moved over. Inner minus 1, which is this 20, just moved to inner position right there. Minus minus inner moves to the left to see if there's more to shift. We'll hit the end of the while loop, the inner while loop, and we'll back up to see if there's more to shift. 0 greater than 0 is a false statement. If the left side of here is false, I don't even have to check the right side. That's false. This whole thing has to be false if 0 greater than 0 is false. There's nothing left to shift. Now, watch what this line does. It says leave the inner loop. When we leave the inner loop, it's time to insert. Let's insert the 10 back into position 0. This is the insert of insertion sort. After shifting the larger values over, we'll insert the 10 back into the array. See this 10? It just slid into position 0, or to inner's position. Note that the 10, the 20, the 30, and the 50 are in order. We've gone through that inner loop 3 times, and these 3 numbers are in position. So let's hit the end of the outer loop and back up. Note, from the start of the array to outer, the array is sorted. The 10, 20, 30, and 50 are in order. Let's go back up. Outer plus plus will move outer to position 4. This is the new outer position right here. 4 less than 5 is a true statement, so we're going to go inside the outer loop. We'll set insert equal to data sub outer. We've just moved this 40 into the insert variable. 40 is the insert value. Larger values to the left need to be shifted. Now this is going to be fairly fast. Only one value, 50, will need to shift. Inner equals outer. Inner will move backwards when larger values need to be shifted. In this case, it's just the 50 that will have to shift. 4 greater than 0 is a true statement. 50 greater than or equal to 40, we're comparing this 50 to that 40 right there. That is a true statement. If both sides are true, we have to shift. Go inside the inner loop, follow this arrow. Let's go inside the inner loop and let's do a shift. 50 is larger than the insert value of 40. Shift larger values to the right. Notice how we're not swapping, we're just moving that 50. 50 just wiped out the 40 that was in there, but 40 is safe in the insert variable. Minus minus inner. Inner moves to the left to see if there's more to shift. We'll hit the end of the while loop and go back up to see if there's more to shift. 3 greater than 0 is a true statement, but 30, this guy right there, greater than 40 is a false statement. When the right side goes false, the whole thing is false. When this while statement goes to false, we will exit the inner loop. There's no need to shift 30 to make room for 40. Let's get out of that inner loop. When we get out of that inner loop, the insert value 40 is going to go to position inner. This is the insert of the insertion sort. After shifting the larger values over, insert 40 back into the array. Notice that this 40 right here just got inserted back into the array. Also note that 10, 20, 30, 40, 50 are in order. We're getting very close to the end of this algorithm. We will still hit the end of the outer loop. and we'll back up. Note from the start of the array to the outer position, the array is in order. 10, 20, 30, 40, 50, everything's looking good. We still need to complete the loop though. Outer plus plus will bump outer to the next position in the array. Notice how it went past the end of the array. This arrow is showing you that outer went past the end of the array. When that happens, outer less than data.length, 5 less than 5, is a clearly false statement. Time to exit the loop. The sort is complete. Boom. Insertion sort is faster than bubble or selection sort. A big reason why it's faster is this inner loop gives up. What do I mean by give up? The problem with bubble and selection sort is it keeps re-looking at the same data over and over. This is a while loop, not a for loop. If either side of this goes to false, it won't keep spinning in the inner loop. It gets an extra speed improvement by giving up. Also, insertion sort is very fast when the data is in near sorted order. What do I mean? If you're sorting a bunch of numbers and only a few of them are out of place, that's where insertion sort really shines.